Alright guys, this is video 2. Remember, each section of the test is being done in one video. There should be 5 total videos, some shorter than others, some longer than others. So here we go. This is questions 3, 4, and 5. Graph each system of equations. Then determine whether the system has no solution, one solution, or infinitely many solutions. If the system has one solution, name it. Okay guys, there's a couple things you have to do before you're done. So let's make sure we do every single thing that we're asked. Okay, so for starters, number 3, it says graph each system of equations. So let's do that first. The top line I'm going to graph in red. Okay, so negative x plus 4 means that I have a y-intercept of 4. So I'm going to go on the y-axis. I'm going to count up to 4. And then it means I have a slope of negative 1. Maybe I should write these out. Y-intercept is 4. Slope is negative 1 over 1. Okay, so starting at our y-intercept, I'm going to rise negative 1. That means I'm going to go down 1, and I'm going to run positive 1, and I'm going to graph my point. And if I wanted to, I could go down again and over again, and I can do this as many times as I want. Okay, so there's my line. Make sure you graph it. Oh, this is not going to be good on the Mimeo, guys. Hopefully you're a little neater than I am, but I'm doing my best here. Okay, I'll graph the second line in blue. So y equals x minus 4. So let's think again. In order to graph this, my y-intercept is negative 4, and my slope in this case is positive 1 over 1. Those are the only two pieces of information we need. So the y-intercept is negative 4. So on the y-axis, I'll go down to negative 4, and then my slope is up 1 over 1, and up 1 over 1. And since my writing's so sloppy, I'm going to continue to go up here and continue to go up here. Guess what? Look where our lines intersect. They intersect right on this point. Not, my line's a little bit off, but right on that point right there. Okay, so graph the system, then determine whether the system has, tell me how many solutions it has. Obviously it has one solution. They intersect right there. So you would say one solution, and then we'll go semicolon. And if it has one solution, please name the solution. Well, where do our lines intersect? 1, 2, 3, 4, comma, 0. That's the intersecting point. Okay, so that is the solution to this system of equations. Now let's do the exact same thing for numbers 4 and 5. Okay, 4 is a little bit tougher though, because as you see, our equations are not currently in slope-intercept form, so it makes it tougher to graph them. So what we have to do first is put them in a slope-intercept form. We need to solve for y. So we'll do equation 1 first. I'm gonna subtract 2x from both sides, and that's gonna leave me with, I'm gonna do my work down here. It's gonna leave me with negative y equals negative 2x minus 3. And then my last step, since this is a negative 1y, I need to get rid of this negative 1, so I'm going to divide by negative 1 on both sides. That means divide everything by negative 1. And I'm going to be left with y equals 2x plus 3. Okay, that's my first guy, so I'll graph the first equation. Y-intercept is positive 3, so 1, 2, 3. And my slope is 2, it's positive 2, or 2 over 1. That means it's a positive 2, so up 2, and I'm going to run 1 to the right because it's positive 1. Or, same thing, I could go down a negative 2 and left a negative 1, because negative 2 divided by negative 1 is also positive 2. So let's try and draw our, oh, geez, that was bad. Wonder if I can just undo that. Yeah, look at that, nice. Okay, so it looks something like that. Then, let's make the second one in blue, so we know which one I'm talking about. So this guy's in blue. 6x minus 3y, same thing. We need to solve for y, so let me get rid of this 6x, and then I'll rewrite this for us. After I subtract 6x on both sides, I still have negative 3y on the left side. 3y equals negative 6x minus 9. And my last step to get y by itself, just like we got rid of the negative 1 right here by dividing, we're going to divide by negative 3. And remember, you got to do everything on both sides. Okay, so we are left with finally y equals 2x, and then negative 9 divided by negative 3 is positive 3. Hey, what do you notice? Our two equations are exactly the same. So I really don't even need to graph my second equation, my blue equation, because it's actually going to fall, and I'll show you, since we have two different colors, it's actually going to fall right on top of the red one. And of course, I'm not going to be able to draw a perfect line right on top of the red one. But if you're drawing with a pencil, yeah, you'd realize they're the exact same line. So that means that there are infinitely many solutions. Don't forget to answer this question. Infinitely many solutions. Okay, we graphed the equations, and then we told how many solutions there were. All right, last one, number 5. X plus y equals negative 2, same thing. This guy's not in slope-intercept form, so you need to put it in a slope-intercept form. We need to get y by itself. So let's subtract x from both sides, and your new equation should be y equals negative x minus 2. So let's graph him. His y-intercept is negative 2. His slope, the slope is negative 1. Okay, so that means, keep this in mind, negative 1 over positive 1. So that means down 1, because that's negative, but to the right 1, because that's positive. And then, of course, you'll draw. Man, I'm just really bad at this. Undo. This is tough. Draw your line. Yep, that's not much better. Okay, and then our last one in blue. Same thing, subtract x. Oops. Subtract x from both sides, because we need to get y by itself. And you end up with y equals negative x plus 3. So 1, 2, 3. That's the y-intercept. My slope is again negative 1. That means down 1, right 1. Hey, guess what? Not only do those lines look like they're parallel, but they are, because if you look at the two lines, they have the same slope. So those lines are parallel. How many solutions do we have? Anytime you have parallel lines, you have no solutions. Alright, folks, I'm going to continue to move on. See you in the next one.